And we were working with determinants here in this video series, and we talked in the previous video about using Cramer's rule, which is a pattern that we use determinants for to solve systems of equations. Now this video is 3 additional problems for you to try. This is problem set 3, and I would like you to try these on a piece of paper using Cramer's rule to solve the systems. Now just a very quick review. Now as I talk about this and kind of go over this diagram real quickly, if this is over your head, if you feel like you've jumped in a little bit too far ahead, then watch the previous video to this, and I've gone over it a little more in detail. So let's just review quickly. A system of equations 2 by 2 means that I have 2 equations, 2 unknowns, x's and y's. All right, so kind of symbolized here by these a's, b's, and c's here. Now what we're going to do is take the coefficients of those 2 equations and write them in a 2 by 2 matrix. It looks like this. We're going to find the determinant of that matrix, and we'll call it D, capital D. All right. Then we're going to use the matrix, a constant matrix here, which are these 2 numbers here, and it's a 1 by 2 matrix, but what we're going to do is substitute it in the x column here for finding the determinant of the x's. And then we're going to substitute it in where the y coefficients go right here in the second column for the determinant of the y. All right. So once we get the determinant from the coefficients and the x determinant and the y determinant, then that can give us our x and y solutions. All right. Now let's try these problems for real. In the previous video I did number 7, so I want you to focus here on 8, 9, and 10 and solve the systems of equations 2 by 2 using Cramer's rule. So pause the video, try it on a piece of paper, and come on back. Alright, so let's analyze what we have here. We have the coefficients here for the x's and the y's is a 2 by 2 matrix. And if we find the determinant of that, let's call it capital D, and that's going to be the determinant of -6, -2, 4, and -5. All right, and the symbol for determinant is just these bars here, like an absolute value symbol. All right, remember what we do is we multiply diagonally in this 2 by 2, so that would be a positive 30, and we're going to subtract -8, which is the product there, and subtracting a -8 actually adds 8. Okay, so the determinant of the coefficients is 38. Next we find the determinant of the x's. Okay, so we'll call that D sub x. Now that's going to be a 2 by 2 matrix of, instead of the x coefficients of the -6 and the +4, which are right here, we're going to substitute in the constant numbers here. So this right here will be a -14, and this will be a -16. All right, remember that that's the substitution. And then I go back to the y coefficients here, -2, -5. So in green, I'll indicate that substitution there. Those are the constant coefficients right there. So we're going to be multiplying across, and -14 times -5 is going to be +70. And we're going to subtract -16 times -2, which is +32. And that will give us 38. Oh, interesting. It looks pretty good so far. This is, of course, very tricky. You got to double check your signs. It's easy to make mistakes. Now let's do the determinant of the y's. All right, so the x coefficients are going to be the same, -6, +4. But instead of the y coefficients, which were -2, -5 right here and right here, we'll substitute in these numbers here from the constants. So -14, -16. So solving the determinant, -6 times -16 is +96. And we're going to subtract this product here, which is a -56. Actually, it means we're adding 56. Note the sign change. All right, total 152. All right, now we're going to put it all together. The x solution is going to be the determinant of the x divided by the determinant of the coefficients. So the determinant of the x is 38. The determinant of the coefficients is also 38, so that would have to be a positive 1. And there we go. Now the y solution is determinant of the y's divided by the determinant of the coefficients. And determinant of the y's we just found was 152. And we're going to divide that by the determinant of 38. And you betcha, that's going to give us a positive 4. And there we go. Sometimes expressed as an ordered pair. That's the solution to the system using Cramer's rule. All right, let's do 9 and 10. I've written this out for you to speed this up a little bit, but what we're going to do is find the determinant of the coefficients, which is this array right here, and that'll give us a negative 1. The determinant of the x's is going to be this determinant here, 2 by 2, giving us a positive 4. And the determinant of the y's is going to be this 2 by 2 matrix. Find the determinant there to be a positive 4 again. Just to double check, for the determinant of the x's, we substitute the constant term coefficients right there in place of the x's. For the determinant of the y's, the x's stay the same, but the y coefficients get substituted by the coefficients or the constants. All right, so that's just a little substitution there. You have to make sure that you copy them down with the correct sign and calculate those 3 determinants right there. Now let's put it together for our solution. So the x solution is the determinant of the x's, which we got was 4, divided by the negative 1 determinant from all the constants up here, and that's why x has to be a negative 4. And the y value solution is determinant of the y's divided by the determinant of the coefficients, and that will give us, again, 4 over negative 1, which is, again, negative 4. So expressed as an ordered pair, solution to the system there, negative 4, negative 4. How'd you do? All right, one more. Let's see how you did on this one. All right, number 10. The determinant of the coefficients is this 2 by 2, negative 3, negative 4, and 0. Notice how there's no y term showing here, so we have to have a coefficient of 0. All right, be careful with that. Make sure you put that in as a placeholder. And that is going to give us our determinant here of negative 18, take away 0, which is negative 18. Hope you got that. Now the determinant of the x coefficients here, substitute the x coefficients for the constant numbers. So it looks like this. We're going to cross multiply and get negative 72, take away 0, negative 72. And the determinant of the y's, the x coefficients, of course, stay the same. Now the y ones are substituted by the constants. And that gives us 48, take away 48, which is 0. Now for the x solution, of course, that's going to be our x determinant, which is negative 72, divided by negative 18, positive 4. All right, the y, this should be pretty simple. We're going to have the y determinant, which is 0, divided by the negative 18 determinant, and that is going to be 0. That's why our solution is the ordered pair for 0. All right, stay tuned for the next video. We're going to work into a 3 by 3 system and using Cramer's rule. Thanks a lot for watching.